Welcome to this entry, which I call the speed of light problem. In fact, there's a pretty basic problem with the speed of light in relativity, and that is the question of what sense does it make? I mean, we have all these theories and formulas, but what does it really mean? And why should relativity exist? For a little thought experiment, let's pretend we can reach the speed of light with the rocket. And our rocket accelerates for a few minutes and then reaches the speed of light. So what happens? What happens is that time dilatation, Lorentz contraction, and relativistic mass comes into effect. And this effect depends on from where you are watching. What happens during acceleration? For the observer from Earth, of course nothing changes. Everything stays the same. But looking towards the space rocket from Earth, we'll see that time passes slower. If you could actually see into the cockpit or like a watch ticking, time passes slower and a clock would tick slower, and it seems that the rocket gets thinner and appears turned slightly, and also the rocket starts getting heavier. For you as the observer inside the rocket, though there's no change in time or distances, also the mass effect stays the same. But looking back to Earth, we see almost the same symptoms that the observer from Earth saw happening to the rocket. So time on Earth seems to pass slower, and clocks would tick slower, and it starts getting thinner and appears to turn. Next, what happens at the speed of light, so the rocket reaching the speed of light. For the observer on Earth, looking to Earth, still there's no change if we neglect the mass relativity. So let's do this for now. And looking towards the rocket, the time inside the rocket has stopped. Well, it's hard to see because the rocket disappeared, and according to mass relativity, it would be infinitely heavy. But I mean, we said to neglect this for now. For you inside the rocket at the speed of light, time still passes normally, so there's no change to it, and distances are also inside the rocket are normal. But looking back to Earth, you see that time on Earth has stopped, and the universe, the inertial universe, has disappeared. It's gone. So maybe I should say a few words to the inertial universe and what's that supposed to mean. And it means that it includes galaxies that are moving slowly compared to the speed of light and slowly relative to each other. For example, the Milky Way would be such a galaxy. And the question on how big they are would be answered by, well, our Sun turns around the center of the Milky Way with a speed of 240 kilometers per second, which is 0.08% of the speed of light. So they are pretty big. To understand why we have to separate into inertial universes here is to look what's beyond the inertial universe, and that's basically galaxies that are moving apart faster than the speed of light. This expansion is unaffected by relativistic effects because it's the space itself that is expanding faster than light. And here's a quote from Panion and Rothstein. It says, "Although it is impossible to move through space locally faster than the speed of light, it is still possible for distances between faraway galaxies to increase faster than the speed of light due to the rate at which the space between them is stretching. This faster than light travel doesn't have any effect on the material that makes up the galaxies. For example, their energy does not become infinite in any meaningful sense, since they aren't really moving with respect to each other in any way that can be measured directly." Let's go back to Earth and our rocket at the speed of light. And we said that time stopped for Earth, the universe disappeared, and there's nothing else but you. And just a reminder, we're still neglecting the effects of relativistic mass, and we come to this in a minute. But the next step is very important, because it says, once at the speed of light, you cannot go back. The universe you came from is gone. And this is a bit paradox, because you might think, I'll just shut down the engine and then you get slower again. But remember, at the speed of light you travel infinitely far in no time. So there's no place to return to. And ask yourself, where do you think you would pop out in the universe after you traveled infinitely far in no time? In fact, your new speed is basically zero, because it can't be determined anymore. There's nothing to relate to. There's no matter anymore. So no time, no space, or no thing to relate to, and you, and we still have the rocket. Well, we know that no mass can reach the speed of light, so basically doing this, what we did, your rocket would have created an infinite mass black hole and thus swallowing the whole universe. But what we can do, though, to keep this thought experiment going, is to imagine that we didn't reach the speed of light with the rocket, but only with our massless consciousness. Then, at the speed of light, your consciousness is floating in eternity without time, and infinity, which is without space. And this leads me to a why, and maybe you saw, or will see, my previous entry about the answer to in how many dimensions we actually live in. And this is why is that what happens at the speed of light the same than the dimension in which that what we really are lives in. Thank you for staying with me that long. There is more to come, so keep your eyes open.